Alright, so here's what I'm hoping to be my last iteration of the CB7 shock tower brace. So I'm going to do some math later to verify, but I just applied a 600-pound load, which sounds pretty excessive for what I would expect this to see. So we look at the stress, and as you'd expect, there's a little bit here. I might round that out to get rid of it. I don't know if it will add too much cost to the machine work. I can't imagine it will. But I've got our yield strength set at 2.5 or 2.75 times 10 to the 8th. What is that, pascals? Yeah. So this is the only spot where there's any stress, but it seems okay. So if that's a concern, then you're going to want to do fatigue. But actually, let me show the displacement here. So this is at a 1-to-1 scale. If you just go to an automatic scale to see what the deformation actually looks like, this is kind of where you're at. So let's go back to the stress and animate. So this is how the stress rises in the part. And as this shows, the max displacement, which is here, is about 0.5 millimeter, which I think is pretty much okay. As you can see, it does not move a whole lot. So once we're okay with the way all the stress look, we'll go to fatigue to make sure that this part is in complete failure. And the loading I've set up is this, it's the static steady, so it's the 600 pounds. And we've got it pushing and pulling with 600 pounds for 1 million cycles, which that's enough. And so then we look at the results. When we see damage, there is no damage anywhere, except for, of course, where this really sharp edge is. So this might even just be because it is a sharp edge. Simulations don't like using sharp edges because they really don't exist in real life. But if we go to the lifes, so what this is essentially saying is these areas will fail at 2.6. Actually, no, that's 263 life cycles. So for this point to fail and these points to fail, it would have to do 1 million cycles at 600 pounds pushing and pulling 263 times. So I imagine that is going to be a pretty good life cycle for this. So I think we're good.